Hi there, my name is Dimitris Charalambidis, and in this video we'll talk about the domain of a function. First of all, let us all remember what a function really is. Let us remember how we actually define the function. A function is basically a rule between two sets that assigns each element of a set A, let's call it the domain of the function, to a unique element of another set B, let's call it range of the function respectively. A function is typically denoted by a symbol such as f or g, which is followed by parentheses containing the input or other else independent variable. The output or dependent variable is then given by the function applied to the input. Let's see an example on that. Consider the function f of x equals to x plus 1. This function maps every real number x to a unique real number that can be taken through the calculations of 2x plus 1. For instance, if we plug in x equals 3, the function outputs the value f of 3, which is equal to 2 times 3 plus 1, which is equal, of course, to 7. Similarly, if we plug in x equals -1, the function will output the value f minus 1, which is taken by 2 times -1 plus 1, which is equal to -1. Now, we mentioned that set A is also called domain of a function. Domain of a function will be defined as that set of all possible input values, also known as the independent variable, the values of the independent variable, for which the function is defined. In more simple words, the domain of a function is the set of values that can be plugged into the function to produce a meaningful output. In more simple words, the domain of a function is the set of all the independent values, of all the input values, for which the function makes sense. For example, the function f of x equals 1 over x is defined for all real numbers except x equals 0, because division by 0 is forbidden. It should be forbidden by law. Therefore, the domain of this function is the set of all real numbers except 0, which in a mathematical notation could be written as domain of f, or you might see it as d of f, equals to x, so that x is different, I forgot to write different here, than 0. It is important to determine the domain of a function, and actually, if it's not clearly stated, that should be the first thing that we should be doing, determine the domain of a function, because if an input value is outside the domain, the function may produce an undefined result. Now, are there any warning cases? Of course they are, otherwise we wouldn't be talking about it. There are several warning cases when dealing with domains of functions, which include, first, dividing by 0. When a function involves division by a variable, the domain of the function must exclude any values of the variable that would make the denominator 0. So keep in mind that when dealing with fractions, we don't want the denominator to be equal to 0. For example, the function f of x equals 1 over x minus 2 is undefined for x equals 2, because if x was equal to 2, then we would be talking about division by 0, which is not allowed. Secondly, negative even square roots. Hear my words, even square roots. When a function involves an even square root, the domain of the function must exclude any values of the variable that would make our subroot expression, the expression under the square root, be equal to a -1. For example, the function g of x equals root of x minus 4 is only defined for values of x being bigger or equal than 4, because taking the square root of a negative number is something that is not allowed as long as we speak about real numbers. And lastly, it's about logarithms. When a function involves a logarithm, the domain of the function must exclude any values of this variable that would result in a negative or even zero argument for the logarithm. For example, the function h of x equals ln of x minus 3 can only be defined for the values that make the x minus 3, the logarithm's argument, strictly bigger than 0. So therefore, it can only be defined for x being bigger than 3, because otherwise the natural logarithm of a non-positive number would not be defined. So once again, from this video, we should keep in mind that the domain is the set of all the input values for which the function would make sense. And when wouldn't the function make sense? First, if it was a fraction and its denominator was equal to 0. Secondly, if it was an even square root and its sub-root expression was smaller than 0. And lastly, if it was a logarithm and its argument was smaller or equal to 0. In the videos that will follow, we will see more examples. We will work more examples on that. But in any case, if you are dealing any misunderstandings, if you have any questions about the concepts we just saw together, you are always more than welcome to leave your comment below the video. As always, thank you for your time.